If streaming. Today I'm gonna review the articles, continue reviewing these articles here. Think I'm gonna spend 1.5 hours on stream and then I'll do a bunch of them off stream. ChatGPT gave me a wrong response on the last one that I did. And the funny thing is that when I replied that it gave me the wrong response, it said that I was correct and it apologized. But yeah, good thing that I'm reviewing the articles. So if left is num's left equals to 2, it's gonna swap them. Or if the right is equal to 0 or 1. Otherwise, it's just gonna navigate the pointers towards the middle of the array. Goes here, it means that it's not 0. I think this seems correct. Place this on ChatGPT. I think for most of this, I'm just gonna do that. I'm gonna put the algorithm on ChatGPT, and then I'm gonna see, like, try to clarify a little bit more, and then move on to the next one. But this one, based on the logic here, seems correct. We have one pointer initialized to the left and the other one at the end of the array, and then based on this logic here is gonna go, they're gonna meet at in the middle, and it's gonna take the ones that are out of order and swap them when it encounters them. It's kind of hard to visualize this swapping though, because it's swapping the numbers in the beginning for the numbers at the end of the array. So I'm not 100% sure that it keeps the elements, like that it starts all the elements. But I think it does because of these previous conditions here. Because if it doesn't match these conditions, then it changes the... So this ensures that you have choose on the left and zeros or ones on the... Choose on the right and zeros or ones on the left. But the problem here is if you have 1 on the left, like if you have 1 and then 0, it's not going to be sorted, because it's not going to change the order. That's the issue. So I think that this might be incorrect. This explanation is incorrect as well. Actually, and this is the one that the last one that I was checking with Python tutor. I'm gonna put this one here. Oh, that's the thing. It's because of the condition here. And because of the way that it decrements and increments. Because I was thinking that it would stop in the middle, but that's not the case because of the conditions. Left is... I don't understand though, like, because, and maybe this is incorrect because, so I'm just gonna ask. Fuck. I was gonna put nums left. Not again. Yeah, so that's the thing. And it seems like for... It's weird because on the other ones there wasn't any mistake, like on the 3 ones. But on these algorithms of these problems, it seems like it has more mistakes. And I think the reason why this happens is probably because it's scraping data from everywhere, obviously, but what it probably does is it gets some solution from somewhere, and then because it doesn't know like how the solution works, it's just scraping the data. It gives the wrong explanation, or it mixes up the code for the solution. Again, same thing here. It's weird. I don't understand how is it possible that it acknowledges that it is a mistake. Maybe it's because of the language that I'm using here, but it's still very trippy to think about. This is just a large language model making connections of weights and biases. As far as I think, haven't studied large language models yet, the machine learning behind them. But I assume that it's just a bunch of weights and biases they're tuned in. And it's weird because sometimes, like in some previous examples, or when I think it was the extended Euclidean algorithm, when I would point something like this out and I was wrong, then it said that I was wrong, and it gave like the explanation, and then I realized that the explanation made sense after thinking more about it. But here it says that I'm right, and it acknowledges that it made a mistake. So it's very, like, how is it possible that if I use the same language in some situations, it's gonna say that I'm wrong and then it is right, but in others it says that it made a mistake. It's very, very interesting. I have no idea how that works out in the weights and biases. It's very crazy to think about. Even the fact that just by giving one line of words, you can put all of this output with all of this context. Like it blows my mind every time that I see this stuff. And it kind of like is weird because I think people like start to take for granted what is actually going on here, what's actually happening. It's really crazy. Like soon people will think it's like it was gonna become the new normal. It's kind of weird to think about. For this one, I think I'm gonna look at another solution, and then we just got another solution. I will just look at neat code again. What I've been doing.
Hey everyone, welcome back, and let's write some more neat code today. So today, let's solve sort colors. This is a pretty good problem. I actually really like this problem. We are given an array of nums, and they give us a little bit of a description, like each value of nums is a color. Let's just skip that because I think it just kind of makes things a little bit overcomplicated. So let's think of it simply. We're given an array of nums and values in this array. Any of the values could be of 3 different integers. Each value could be a 0, 1, or a 2. We want to take this array and sort it in ascending order, right? So this is the array. We want it to be ascending order, 0s first, 1s next, and then 2s. Pretty straightforward. But there's many different ways to solve this problem with varying efficiencies and varying memory complexities. So then they tell us right after that we can't use like a library sorting function because of course library sorting functions run in and log in time. It would just be a single function.
I guess I could try to solve the problem as well, but I don't feel like thinking, so it's just easier to get the solution. And this is the main problem I have with stuff like this, is that these kinds of tests and things that people have to do, because it's the way that the system works, is that it forces you to think about problems that don't matter, like for you at least. Maybe this is a problem that is useful somewhere, but because like there's a disconnection between what people do and the problems they're gonna solve, and these tests here, which it feels like it's just spending time and then energy thinking about something that doesn't matter at all, and I hate that. So that's why I don't like doing these challenges. Like all the time that I try to do them, I just keep thinking about this, like why I'm wasting my time here, like trying to come up with a solution for something that I don't give a fuck about.
Sort on this array, but I guess we could implement our own sorting function, which would also end up being n log n, whether you do merge sort, or I think quick sort also has the same average time complexity, right? So we can implement our own sorting and do it in n log n time, but we can see that this problem is a little bit more simple than just a regular sorting problem because we are given only 3 values in the array, only 3 potential values. So if you've heard of the algorithm bucket sort, then right off the bat, you're gonna think, yeah, this problem can be solved with bucket sort.
So I think one way to improve that is that context really matter. So I think that the best way to improve that would be, instead of doing challenges like this, creating a problem in website development, for example, or a problem that is common in like businesses actually, that people use all the time. So maybe some machine learning problem or something like that, where a part of the problem is figuring out the solution to manipulate these data structures, because I believe that this happens all the time. Like one example is the blog thing that I was doing, that it is a software engineering problem because you have to think about the algorithms and how it's going to connect with everything. But because the context is different, then it makes a lot more sense for people to train. So another example would be like creating a problem of filtering products to show on a page, and then the products have to be like either on a certain price range, or based on a machine learning algorithm, they have to be congruent with some data. And then because of that, you have to create this algorithm that changes the array in a specific way. And that would be, for me, a much better problem to focus on, and it would be a lot more interesting because it's actually something that you can see how useful it's going to be if you find a solution. So I think this is the major problem that these problems here have, that is not, like, you can't see the connection. So it seems like it's something that people are forcing you to do because it's the nature of the system.
In linear time, we can sort this into array in linear time. Reason being is we know there's only 3 different buckets. If the values range from 0 to n, where n could be an arbitrarily large value, then of course we could not do this in log n time. But we know the values are only between 0 and 2. We can do bucket sort. Now what is bucket sort, and how are we going to use it to solve this problem in linear time? Well, we're going to say we have 3 buckets.
And it's the same issue I have with some of these papers on mathematics, because another thing that happens with human beings, I think, is that because how much you get paid and how well you do in a society depends on how likely you are to be the person that has the best view of the future, let's say, the best vision, because that dictates the systems we build. So everything is based on certainty and assertion. So people want to present themselves as being, as knowing more than they know, because that's going to help them climb the ladder. And everyone is incentivized to do that. That's why it's so hard to be open-minded and to question yourself. And because then you give your power away for people that seem to be more assertive of what they believe. And the problem is that this creates these things where people tend to make the things that they are doing harder. They tend to make it seem harder than they are. So like they are overcomplicating the thing just so they inflate their self, let's say, so that they're viewed on a higher status and they make more money. And like it becomes this thing where most of the time is, and I think like this is natural human condition, so everyone does that even subconsciously, but then it creates these things where like there's a lot of problems that are way overcomplicated because, or the language that people say is like way overcomplicated because it's just everyone wants to make it seem that what they're doing is harder than it actually is. And that's a very big thing on engineering as well. I remember everyone says that engineering is super hard and all of that stuff. And most of that, I think, is garbage. It's just people trying to make it seem more difficult than it actually is, so that they are placed on a higher ladder of status, I think. But everyone does that. I do that as well. Like, I think it's a natural human condition, but it's very annoying when you encounter this kind of stuff.
One, a 0 bucket, a 1 bucket, and a 2 bucket, and for each of these buckets, we're simply going to scan the input array and count how many of each of these values occur in the array. So yes, we are going to need extra memory, but really this is going to be like a hash map or an array of size 3, right? This is going to be an array of size 3, so we're counting 2, so we have a single 2 so far, we have a single 0, we have another 2, so let's say the number 2 is 2, then we get 2 1s, so yes, we have 2 1s, and then another 0, so in reality we have 2 of each of these values. Now we want to build the output array, but we are going to create a separate output array that wants to do this in place, we can see above. So what we're going to do is, we know we have 2 zeros, let's just go at the beginning, first 2 values, cross these out, replace them with 2 zeros, just like in the output array. Again, we're going to the 0 portion, right? 2 zeros from the beginning. Next we know 1s go right after zeros, so we're going to take these 2 1s, put cross out these 2 values, right, and then add 2 1s right after the zeros. And the exact same thing with the 2s, right? We have 2 2s, so that's going to make the remaining portion of the array. We can place those 2 2s at the end, right? So we're overwriting this memory, so we're not actually using memory, so this is O n time solution and O of 1 solution. This solution in terms of complexity is about as good as it gets, but this is such a trivial solution. I'm actually going to show you the slightly more hard solution, which is actually the one pass solution we can see. In this case, we actually have to go through the entire input array twice, once to create these buckets, and then once to actually build the output array. But we can technically do it with a single pass, which is a slightly harder solution. That's what I'm going to show you today. That's what we're going to code up. So before I show you the solution, my first question to you is: have you heard of the algorithm quicksort? In particular, do you know the portion of quicksort that requires the partition algorithm? Do you know how to partition an array? For example, let's say we had an array and we wanted every single value n value which is less than 5 to go in the left portion of the array. And if we did that, let's say we had an array like 1, 2, 6, 7 of these values. We wanted the values that are less than 5 to go in the left portion of the array. If we did that, what does that mean? Well, then we took these values, put them in the left portion of the array. If we did that by swapping values around, if these 2 values are over here, let's say the size of the array is 4 values, these original 4 values. If we took these and put them in the left, that means by default these 2 values which are greater than or equal to 5 are going to go in the right portion of the array by default. Right? That's called partitioning an array. That's the same idea we're going to use here. So remember, I want the zeros to go to the beginning, the 1s go to the 1s go to the end. So let's partition the array using the same idea. We're going to go through every single value in the array, right? The example, let's say, and every time we get a 0, the way this partition algorithm works is we just have a single pointer at the left. Right? It's basically we're going to call this the left, right? It's designated at the beginning, all the way left. We're going to have I just run through the entire array. Anytime you get a 0 value, we're going to take that 0 value, this one over here. We're going to take that 0 value, swap it with the values over here. Right? The values over here is not going to be a 0, right? So whatever is negative 1, negative 2, we're going to swap it over here, and that 0 is going to go over here. So then once we have a 0 value, we can take our left pointer and shift it over here. Right? Because then you know the next time you encounter a 0, we want to put it in this position. Now, of course, what happens if the first value by itself already is 0, right? And then swapping with itself, which is perfectly fine. And then we take our left pointer and shift it here. So it works out in both cases. So let's say we do that. Let's say we run through the entire array. With our array level, in this example, we'll have 2 zeros being at the end, but then we'll have a remaining portion between some 1s and 2s in some arbitrary order. We don't know the order of these. So we successfully partition the array. We got all the zeros at the beginning. This is one partition. Now we still need to partition this, right? We put both these 1s at the beginning and then take all the 2s and put them at the end, right? But remember, if we do like this, then we're doing 2 passes, right? It's basically a lot of our part. Let's do this in a single pass. So let's maybe try to modify this partition idea. How about we take all zeros, put them here, use our left pointer, but why not have a second pointer, which is always going to be upper right with our right pointer, and then anytime we encounter a 2, we put a 2 over here. Anytime we encounter a 0, we put a 0 over here. We shift our left pointer accordingly. If we end up putting 2 here, we take our right pointer and shift it accordingly to the next position. So this idea is definitely work. There's just one edge case right now. I'm going to show you that edge case. Let's say we got this random scenario where our left pointer is going to be over here, designating to us everything to the left over here is already a 0. Right? Of course, the left pointer is 0, everything to the 0 makes sense. And our right pointer is going to be over here, which is going to designate to us that everything to the right of it is supposed to be a 2, which makes sense.
Maybe you should try to use ChatGPT to fix this algorithm. Try to understand it first and then fix it. Yeah, it's not sorted at all. At the end, it just returns this one. So I think is bubble sort the name. I don't remember really well, but I know there is an algorithm to split the array in two parts, and then you keep splitting them recursively, and then you compare each one, like sort each one at the top, the lower level, let's say. Maybe, but that doesn't use the two pointer. I think it's just another way to solve it. It's really hard for me to think about a way to solve if it starts the other pointer at the end of the array, because then any swapping I do, like I would have to go back eventually to other ones, because there might be a chance that some of them were not swapped. So I think that the answer must be on the way that you move the pointers. So maybe removing this thing here. If I do this and then I swap here as well. And then I the problem is that I don't know where the nums left is gonna be. So another way maybe is to put AND statements. But I think if I don't want to think about, I might spend a long time trying to figure out. The solution is basically gonna be the control flow. Based, you have 2 pointers, and then based on the control flow you do here, the way that it is gonna navigate the 2 pointers is gonna sort the array. So the challenge is figuring out what is the right conditions to move the pointers so that at the end you sort all of the elements. And it's hard for me to think about a way, because like, it's hard to think about the boundary of the elements of when you should move one pointer and the other. It's obviously on the extremes where you have zeros and twos. Then you move the pointers, and if you have twos on the right, then you move the right pointer to the left. And if you have 0 on the left, then you move the left pointer to the right. So that is obvious, but then the challenge is on the middle. So what do you do when you have or in the middle, or when you have the two switched? Because then it might be the case that you switch two elements. Like let's say you have a 1 on the left and a 0 on the right. Then if you switch both of them, you still have a 1 on the right, and that 1 might come after some twos that exist. But then at that point you would have the right pointer on the left already, which means that you would leave the one element there. So let's say you have true, 1, true, let's say, for example. And then in the beginning you have some zeros, and then in the middle you have some. So in this case, if you swap this for this, or it's the other way around. Here, 1, here, 0. So if you swap this for this, then the right pointer would move to this one, but here is 1, and this is not correct. So that's the challenge, is that how do you make sure that the 2 are here, not the 1? After you move the pointer already. I think I'm just gonna look at the solution for, or maybe get an arbitrary solution.
Found right. We move over here into our right corner and shift it by 1 over here, right? And every time we encounter a value, like we our right corner, this is where we can see it. I'm going to shift our right corner to the next position, right? Because one thing that we worry about. Take a look over here. Our left corner could be pointing at a 1 value, right? Because if we encounter a 1 value, we're just going to see our right corner over here. Our right corner is here in this example. Our left corner, yes, could be pointing at 1, but notice our left corner is never going to be pointing at 2 because it was, we would have already swapped it and put it towards the right. Right? You see our right corner, so we pass this decision. So if it was a 2, we would have already swapped it over there. Since it's not, that must mean always going to be a 1, which is good for us. But you'll notice with the right corner, anything to the right corner is going to do. The right corner could be pointing at a 0, or it could be pointing at a 1, or it could be pointing at a 2, maybe, right? And if it's pointing at a 0, that's going to be a problem for us because what happens now? Our right corner is going to see a 2 here, and our passes our right corner, and we're going to have the corner. I was just going to the entire array. So we see our right corner. So while I is left, right, let's continue. So there's 2 cases we worry about. If the value of our is either a 0, or if the value of our is a 1. So nums I is equal to, or maybe it's a 1, but if nums I is equal to 2, right? That's our right case. So in both these cases we're going to swap, right? So we're going to swap both these cases. Our right is going to find a function, so we're going to have 2 corners, the indices of nums that we're going to swap. So it's a value for nums I. We're not passing nums into this function, since this function is defined inside another function. We are using our required passing that variable. It has access to a variable outside of it. So let's get nums I store in temp and replace nums I with nums of j, and then do the exact same thing with nums of j, swapping it with a temp variable, which is originally nums I. We're swapping the 2 values I and j. So that's helpful for us. So if I equals 0, then that means we're swapping this to the left corner. So let's swap on our left corner and our I index. We're swapping these 2 values. And we do that, we never increment our left corner, right? By 1. The else condition is if it's equal to 2, and next we're also going to swap, we're going to swap the index I and our right corner, right? And if we do that, we're going to take our right corner and decrement by 1. Now in either case, remember we want to increment I every single time, but remember if we form a right swap, we don't want to increment I. So in this case I'm going to say, but if we encounter 2, remember we don't want to increment I. So in this case I'm going to be decrement I, and that's going to cancel out by incrementing our right outside it. Because next every single time, so if we encounter 1, we're going to enter these integers, we're also going to increment our right corner. And then outside, remember for anything, we just modify the numbers right in place, which is exactly what we did with the swap function. So this is the entire code. You can see it's very efficient. This is the one pass solution. So I hope you found this helpful. If it was, please like and subscribe. Support the channel a lot, and I'll hopefully see you very soon. Thanks for watching. The swap function. So this is the entire code. You can see it's very efficient. This is the one pass solution. So I hope you found this helpful. If it was, please like and subscribe. Right outside it, which is every single time. So if we encounter 1, we're going to enter these integers, we're also going to increment our
Another thing I could do is just put the NeetCode channel, embed this video on the article. And maybe, I don't know, maybe it's a waste of time to do these articles. I think it's good for studying, but it's probably a waste of time to put them there. I don't care about this stuff either, so... I think I will reveal them, only not put them there. I'm only gonna put ones that I think are interesting. So the ones I already have, I'm gonna leave it there, but... And then I'm gonna review just to study, to see how the problems, what the problems look like, and the solution. The graph ones I wanted to do because I wanted to understand more how it works. So I think it was good to leave those on, and these ones as well. But the 3 ones I was thinking more about getting like some other problems as well from LeetCode. Based on the way that I did the prompt on ChatGPT, I got these ones, but I think it's fine as well. It's just a review on this stuff of machine learning. And so I think what I'm gonna do is just delete this I'm not gonna put these ones. I think I'm just gonna put the ones that seem interesting to me. And the other ones I'm just gonna look at the solution.
Alright, and then outside number
Let's see here. So it's swapping the left with zeros and the right with twos. Well, what about the ones? I think the ones in the end are going to be sorted by default. So that's the point. But what if the first element is true? What happens then? The C is going to be true, then I is going to become -1. Alright, I guess it doesn't matter. I don't understand why, because it's summoning I here as well. So the effect of decreasing is gonna be, it's not gonna make sense because it's gonna increase anyway after. Oh, but when he hits this one, is that, yeah, but it still doesn't matter. So I don't understand why I put I minus equals 1 here. What's the point? Yeah, that's the thing. Why not delete the line on 21 only? Oh, it's because when hmm. Yeah, I think it's because of the ones in the original array. Because it is gonna just increase when it's here, but here it stays the same. That's why. And so you can either do it this way, or you can put I plus 1 on the else statement. I think I get it. But I'm not gonna put this article there, I think. I'm just gonna delete this and move on to the next. I think this one is easy. I remember doing this one, so I'm gonna leave this one for later. And I'm probably not gonna put any of these actually. Just gonna delete them because I don't care about this stuff. I think it's good though to review because then I get some practice or I look at a bunch of problems that people ask in coding interviews. That's the thing that I don't know as well, is because I never done an interview yet, so I don't know how it is. Then maybe if I do a bunch of them and all of them, and I see that I can solve the problems and they are requiring, then I might have to do this, even though I think it's stupid. Blah blah blah. I'm gonna delete this one. I think I get it, but I'm gonna delete it. Maybe I should do 3 ones again and then just get another 10 that are more related to lead code problems. Yes, I am interested on the 3 ones. Or maybe I should do the 3 with TRIE, the one for the letters, which is also related to blockchain. Should be interesting. And this one is really simple. I remember solving this one as well. I think I'm gonna delete this one as well. So yeah, let me investigate this one. I think the ones that will probably be the most interesting are this one, the heap, and the linked list. Not linked list, the math and geometry. And math and geometry, trees, or tries, however you say this, on heap and priority queue. And the dynamic programming maybe because I remember it was really hard as well to understand. And the rest, I think, maybe bit manipulation as well. I think I get it. So children are the letters inside of the words. Each tree node is a word, I think. And then I have a fast dictionary of words. And then make currents equal to the root, which is this tree node. Current.children. Which is the roots, the root word, I think. And the children charm is tree and all. If it is not on the children is going to initialize as a tree node. This guy is going to be a tree of trees.
Special.
I'm searching for the characters in root children. So I think I get it. So it's gonna traverse all the characters, which each character is a key value pair. So I have the character, and then character is a key, and then the tree node as a value. And then the tree node is gonna contain the other words. So if all of them exist, it's gonna return true. Cons. That's the one. I don't understand why though. Why it makes this condition here. This is not increasing the count here. So it means that this is gonna run like either way. Because it's passing 0 here, so. Like why make this condition and not just put the whole thing there? Like why not just make like this? Or maybe it's because of the recursion. But it still doesn't make sense because the count is never changed in the recursion. But no. The word doesn't change either. Yeah, but if you don't, it doesn't make sense. I don't think it's because of the recursion here. Oh, I get it. It's because of this condition. So it is because of the recursion. But this doesn't make sense to me either. Or maybe it does. Because here is gonna return false. Like, because count is 0, so. Oh, I didn't look into this recursion though. That's the one that increases. Oh, so now it makes sense. I was just looking at this part here. It's going over the... So this one goes over the keys and this one goes over the values, I think. That's what's happening. As this one is gonna call this one again. So it goes recursively for each branch of the tree. And if you don't put this here, then it doesn't go over the other values, the other keys. I think I get it now, so... I'm not sure if this is correct though. Oh, I get it. Also correct because there is no words. So it allows you to change one character. Because lead code has one extra character, you can't modify it, your get. Yeah, but then I guess you can add characters but not remove them. But here it is going to through the values of the children through here. I'm trying to picture what it's gonna look like once all of the words are part of the method. Let's here. And so once you put all these words here, what that is gonna look like? So I can understand the search method more. Because I don't understand why the second one here is false, but this one is true. I guess it's because you can add one character, but you can't remove one. But I don't understand how the search method does that. How does it check for that? Sharing words, share not secret to children. Yeah, so it adds the character as a tree node there on the root. Oh, and then it puts this value here once it reaches the end of this loop, because the current one is going to be a word. The path to the current one is going to be a word. So I think I understand this method here. It's not that hard to understand. And this just moves the pointer each iteration. So it goes inside of the nested tree node inside of the root. So it goes from the root, then creates another tree node, and then from that tree node it creates more if they don't exist already. If they exist, then just traverses through the ones that exist and adds the characters. So I think I understand this one. And this one is the hardest to understand because of recursion. It passes the root and the word and the counter. Okay. And so this checks to see if you got to the end of the word. Count equals to 1. So it's only gonna return true. So I guess what these true methods are doing is checking to see if you either have the true if statements here. If you either have the word on the thing, or if you can modify one character. If that's the case, then it returns here. So this is the base case, and then this should traverse traverse recursively using that for search. So if the character is on the children, returns this. So if it is not, then it means that it's false, because the word doesn't exist. And that's one of the things that is hard to understand. Because, like, let's say you have a word that, but I guess if the ladder doesn't exist at the top level, then it means that the word is not going to exist as well. But wouldn't that depend on the way that you place the words? Each word first? Because then depending on the way that you put them, they're going to be connected in different ways. That's what's hard to understand. Because of the way that this method works. Children's. Oh, yeah, I guess it doesn't, like, it works like that because it eventually is gonna have all the characters at the top that form a unique word. I think that I get it now. So if this fails, it means the word that doesn't exist, so it's gonna return false. If the first character of the word is not in the children, because it's not at the top level, it means the word doesn't exist. But if it is, then it goes recursively and returns true here. So this is checking to see if you can traverse the children to get the next characters of the thing, the word. So it's traversing through the children's, the value of the children's, to see if you can get the other, and then if it counts, then it goes through the values. The thing I don't understand is why, because here is the value of the children, but I guess here is going from the like from the top node and traversing that way through the children, and here is going from all the top nodes and traversing that way, I think. Yeah, that's the thing. But I don't understand the count though. Because the count has to be exactly 1 to return through there. It's only gonna run this once. I guess this one checks to see if it didn't miss anything. Because it's gonna run through this once and then it's gonna go over this one again. It's very difficult to understand because of the recursion. Also, it's pretty much like this is the method that checks to see, is allowing you to change one character. That's why it has the count here. I think I get it. So it traverses the thing, but then somewhere the characters might not be on the node.children, which means that it's gonna hit this one, and then it's gonna get the values at the current level, and then it's gonna traverse through those values to see if you could get another word in the value that exists. And then it's gonna increase the counter. I think I understand. It's very hard to understand how. It's because you have wonderful here. No, but that doesn't make sense. Because it's still on the 4th index. Yeah, I think I understand. So this one, when it gets to the O here, is gonna run this method here. And this method is gonna allow it to get the R there. It's hard to think about because of the levels of how each word exists on each level of the tree. And the thing is, it can only run this thing once. Oh, but so let's say this is O. It doesn't exist, then it's gonna go here, it's gonna get the values. Children values. Maybe it's because it gets from this one. gets the error from this one. But that wouldn't make sense as well. Maybe that's because it's not this R is on the 5th level. It's because it depends on the structure of the tree. That's why it's confusing. Because you don't know, just by looking at this, it's very hard to picture how the words are going to be, the characters are going to be structured in the connection of the nodes. To know at which level this is going to stop at. Because this is only going to get the values of the current children of the word. So imagine that when it hits the character O, then it's going to go here. And then it's going to get the values of the children of O. And then it's going to go here. And this is going to be R, I think, at that point. And R is going to exist on the children, so it's going to return true. This is going to keep traversing. And then at the end, the count is going to be 1, which means that it's true. And the weird thing is that count is always equal to 1 here as well. That's another thing that is hard to understand. It means you will have to go over this anyway, so that it returns true in the base case. Yeah, that's the thing. So I guess the function is not like the best. And that doesn't make sense either. That doesn't make any sense to me. Because the point is to find the word, and also that the word itself is not gonna be, unless it's a character or not a word, it's not gonna be on the tree, on the children. So the problem here is that it requires you to check for one character to be modified, but then if you don't modify one character, then it says that it's not gonna exist, which is obviously incorrect, I think. Oh, how would I fix this? I think it's confusing also is the whole thing about the levels that I talked about. Because depending on which level you get to this point here, it might be the case that the children don't have the values of the children don't have the words, but then child node and children device. I guess this just skips the word, so it doesn't matter. That's what's happening. I don't know why he returned true here though. Because it's only gonna hit this one time, I think. And then it's gonna go back. I guess it's because at the end of the recursions, it's gonna return true. But in my mind, couldn't this also be like this? And then without the thing here? Because you're never gonna hit this condition again. Oh, unless actually... And because it may be the case... Let me think. I'm not 100% sure that this is necessary. But it may be the case that it hits... but actually not, because it's checking to see if it's greater than 1. Yeah, so I don't understand why this is necessary here. Because if this returns false, then it means that it's not gonna run, and if it returns true, it seems redundant, because it's only gonna go here once anyways. So I think it does make sense here, where you're checking the values of the children, because if that current word is not in the children of the current node, it might be on the values. So it's like you're skipping one level, because you're allowed to have one missing word. So this allows you to skip one level one time. And then it does this recursion here, which is gonna make it so that it hits this point again, but on another level, because you're increasing the value here. But you're doing that throughout the child. And this is the thing that doesn't make sense also. Because I don't know like what count is gonna be. I guess you're just investigating all of them. But if every time you run this, and you're gonna run this for all the child, for all the values here, then you're gonna increase count by one more than one, regardless. So which would mean that anytime you hit this, it would return false anyway, because you're increasing count more than one, if there is more than one value in this node children here, because the loop is gonna run twice and then it's gonna recurse twice here, increasing the count more than... But it wouldn't increase the count because it wouldn't hit here. But that's the thing that I don't know. Like if it's gonna run the loop anyway. I think it does run the loop anyway for all of it tests for all the child, I think. But then it doesn't increase count, because count is gonna be greater than 1. So it investigates all the values here through this recursion. So it's like for each child here is running this loop, actually, this if statement here, and then running the FS from that child. This is kind of like forgiving one level if it's wrong, and then through the recursion it investigates all the other in the same way that did here through this other depth search. So I think this makes sense actually. I think this algorithm is correct. The only part that isn't correct is this one, because it's not necessary for the count to be 1 if the word is exactly the same. So maybe the way to change this is just put R here down. Because then it means that it's either a word or the count is 1. So I think like this is correct. So I think it's both that and both adding, but this condition would be different. You would have to return true here, but then it's not really a word, it's a character. Because if you're passing a character, then the character exists. And I think that it would work anyway, because you would say, yeah, but it wouldn't work because then it wouldn't be, the word wouldn't be true. Because it wouldn't be the end of a word if you pass a character. But I guess that, like, and if you want to solve for that, then you just put the true here instead, I think. But if you put true here, then it's gonna fail on the recursion, that's the problem. No, actually not, because you're testing the word. So yeah, maybe if you put true here, then it would work for that case, but I don't think it's necessary. That's the problem. Yeah, so that's the issue. Yeah, in this situation I think it works, because then if you reach the end of the, when I is equal to the length, and you still didn't get the word, then it returns false. But then what about the count? Because then you would allow it to count more than once. So I think the simple thing is just put and there. So and counts equals 1. And there, but then it's the same thing as the other one. That's the problem. So maybe if I put count equals 1, but if I put R, it's gonna be the same problem. So I could put if node is word is true, and if so let me go back to the way that it was then. But that's the thing. So if I put like this, maybe it works. And then put false here. Because now I'm testing this one first. But then I don't test. Unless I put this one as well here. I'm just testing both the situations. Because I want to allow for either this should be true or this. Yeah, there we go. So I think this works. Not sure. It doesn't look like it is the best, but I'm not gonna spend time trying to figure out what would be the best. And I think that's good enough. The reason why it looks weird is because I'm testing this like multiple times here, putting and this. It makes me think that and here this condition as well. But the thing that is tricky is that you have to think about all the recursions here to figure out what's the best way to test for the conditions here. Yeah, there we go. I think I'm gonna leave it like this. And maybe I could put some stuff here to explain like what I did there. Or explain how this recursion works. But I think I'm not gonna spend time on this. I'm gonna try to get to try to finish these trees and then look into these ones that I think are interesting. I think the rest I'm not gonna. Maybe I should review all of them, but not put all of them on the blog. This one I also think I'm not gonna put there because I already have an article on data structures, so I think that is better to just leave that as a data structure. And this one is a lot more simple. I think I understand. It just deletes the. Wait, is it deletes the words as it goes here. And then if searches for in the tree using that first search. And then this checks to see if it's the longest. If it is, it replaces. I don't understand this though. Word plus sure. I guess it's just increasing the word. So it's like it's storing the words through that first search. Like adding to this empty string here. While it reduces the main one. It's kind of hard to understand though. No, so I think I got it. It's traversing the tree here through the characters and then checking against this string there. And then it cuts the strings. It adds to the word. It adds the character to the word. I think I understand now. And I think it is correct. Yeah, at the end it just returns the word. And so what it's doing is looping through the children for each character. The children are gonna be each character, starting from the root, and obviously the tree is gonna be made of these words, which is gonna be the connection of different letters, different characters through the pointers. And then here is gonna be the index, and then it's gonna go search recursively through the pointers, passing each character and then adding the character to the word. And then when it gets to the point that is a word, it's gonna change the result. And the non-local here is used to access this. And this shrinks the main string. It cuts down based on the index of the character. So it's like it's deleting the characters. But it's kind of hard to understand because of the middle characters here. So this word, for example, if you reach C here, for example, is the way that is cutting the string. I don't know if it's like how is it gonna work. And so it's getting the left side, yeah. So just checking to see if the character is using S and then it's traversing through the character there. And then each time it does, it cuts the string from the right to keep traversing. I think I understand, I think it's cracked, so I'm just gonna put that on the blog. I think I'm gonna remove this thing here. I'm not sure if it's correct or not. Yeah, I think I'm gonna put this one there. I think. All these words, dictionary. It's just summing the values of the nodes. And then each prefix is gonna change the value, I think, based on what you pass here. And this is a easy one to understand, I think. Yeah, blah blah blah. So I think I'm gonna move this one there. Really easy to understand. It's pretty much like a tree, but then you can use prefix and you can add values to the prefix. Just gonna create subtrees with different values, and then in order to get the sum, you just call recursively here and add the values. Pretty easy. And this is the same methods as the other ones to insert the words. And the difference is using a key here. Chart including children, then it adds values at 3 nodes, otherwise it just moves through the other one. Then at the end it places the value. Yeah, I'm gonna move on to the next. Let's see how much time I have. Oh, I didn't put timer. Yeah, so I think I'm gonna stop here. I'm gonna go eat something. And I think I'm gonna continue to do this off stream. I wanna review all of these 3 ones, and then I'll check it out to see if there's anything interesting on these other ones. But I think what I'm gonna leave the articles here, I'm not gonna delete them, but I think what I most likely will do is just check on the ones that I think are more interesting now, which is the heap, and maybe the math and geometry, and I think that's about it. Maybe the dynamic programming ones as well. So if I see that there's anyone that I think that it might be interesting, then I might do it. Or otherwise, I think what I'm gonna do after I finish these ones that I think are interesting is work on the poker software thing, and then go back to focusing on blockchain ones. Because I'm just putting these articles here for volume, so I have more articles on the blog, but I don't really care about this stuff. So that's why I think that's the best strategy. So I'm gonna skim through all of them, and then I'm not gonna delete them because I think that maybe after I start working on poker software or blockchain stuff, I can go back if I want to, and then just include the ones that I decided not to do it. But I think I'm not gonna end up putting these articles here, most of them, because it doesn't feel like something that I really don't care about, and it feels like it doesn't matter to put there or not. It's kind of like a waste of time. And I think it is good to look at them because then I familiarize myself with the problems, but I don't care about this. So yeah. So I might come back today after reviewing a bunch of this to work on poker stuff. But if not, I'm probably gonna come back Monday. Or maybe tomorrow, but most likely Monday.